In this video, I want to look at an example from the ALEX homework for finding the domain of the composition of two functions. In this example, we have g of x equals x squared minus 5 and h of x equals square root of x minus 6. We want to start by finding g of h and then specify its domain using interval notation. So remember, g of h means that I'm going to take the h function and plug it into g wherever I see an x. So since g is x squared minus 5, I'm going to take h, which is square root of x minus 6. I'll go ahead and square that and then subtract 5. So the square root and the square undo each other. And so I end up with x minus 6 minus 5, which would give me x minus 11. So I'm going to go ahead and type that in over here. That's my composition of the two functions. Now the domain is a little more complicated. If I just look at g of h, that's a linear function. And so the domain, if I'm just looking at a linear function, the domain would be all real numbers. But what we have to remember is that our original h of x had a restricted domain. So since I'm plugging h of x into g of x, I will be restricted by what the domain of h was. Now for a square root, we know that the part underneath the square root has to be greater than or equal to 0. So for the domain, I'm going to have x minus 6 is greater than or equal to 0. So that would give me x is greater than or equal to 6, which would translate in interval notation to the option where I am including the 6 by using a bracket and then going to infinity. All right, let's do another example. And let me go ahead and clear my ink there. Okay, so here we have g of x equals the square root of 5x plus 35. And h of x equals x minus 4. And we want to find g of h. So I'm going to go ahead and have my g of h of x. So I'll have the square root of 5. And instead of an x, I'm going to write x minus 4 plus 35. And I want to go ahead and simplify that. So I'll get the square root of 5x minus 20 plus 35. So the square root of 5x plus 15. So here, when I'm looking at the domain, I want to look at the 5x plus 15. Set that to be greater than or equal to 0. So 5x is greater than or equal to negative 15. So x is greater than or equal to negative 3. And notice that's a more strict restriction than the g of x domain. The g of x domain, I would have x needing to be greater than or equal to negative 7. So I've set a stricter restriction based on my outcome. So I'll go ahead and put in my square root. There it is. So square root of 5x plus 15 And I'm going to choose the option with the -3 included. And I'll have -3 to infinity. All right. We'll do one more with the square root. So I'm going to find g of h, where g of x is x squared plus 5, and h of x is square root of x plus 2. So just like before, when I'm trying to compose the two functions, I will have g of h of x. I'm going to plug the h of x into the x in g. So I'm going to have square root of x plus 2 quantity squared plus 5. And that would give me x plus 2 plus 5. So my result is x plus 7. However, for the domain, I'm restricted by the domain of my original inner function. And my inner function, h of x, had a domain of x plus 2 greater than or equal to 0, because I can't take the square root of a negative. So x is greater than or equal to -2. So even though my composition function came out as a line, which should have a domain of all real numbers, I'm restricted by the function that's getting plugged in to g. So I would have x plus 7, and then including the -2, I would do a bracket -2 to infinity.